Take a moment and look around you. The chair you're sitting on, the phone in your hand, the keyboard beneath your fingers, the water bottle on your desk, even parts of the clothes you're wearing. What if I told you that almost every one of these objects began as the same substance? Not metal, not wood, not glass, but a thick black liquid buried thousands of meters beneath the Earth's surface. Crude oil. Every year, humanity produces hundreds of millions of tons of plastic. Yet very few people know the extraordinary journey that transforms ancient underground oil into the everyday products that shape modern life. This is the incredible story of how oil becomes plastic.
Plastic is everywhere. It protects our food, keeps hospitals sterile, makes cars lighter, insulates electrical systems, connects the internet through fiber optic cables. Even the smartphone you're watching this on contains dozens of plastic components. Its popularity comes from a remarkable combination of properties. Plastic is lightweight, durable, corrosion-resistant, inexpensive to manufacture, and can be molded into almost any shape imaginable. Without plastic, modern medicine, transportation, communication, and countless everyday products would look completely different. But before plastic can transform our world, its story begins millions of years in the past.
Long before humans existed, vast oceans covered much of the Earth. Tiny marine organisms lived, reproduced, and eventually settled onto the seafloor after they died. Over millions of years, these organic remains became buried beneath layers of sediment. As pressure increased and temperatures slowly rose deep underground, the organic material underwent an extraordinary transformation. It gradually changed into crude oil and natural gas. These underground reservoirs remained hidden for millions of years, waiting to be discovered. Today, they provide the raw material for one of humanity's most versatile inventions: plastic. Before plastic can be manufactured, crude oil must first be located beneath the Earth's surface. Geologists use satellite imagery, geological mapping, seismic surveys, and advanced computer models to identify promising locations ever built. Once a potential reservoir is confirmed, drilling begins. Massive drilling rigs bore deep into the Earth, sometimes extending several kilometers below the surface. Onshore wells and offshore platforms extract crude oil continuously, pumping millions of barrels every day. The oil is then transported through pipelines, tanker ships, and rail networks to one of the most complex industrial facilities ever built: the Oil Refinery. At first glance, a refinery looks like a maze of towering columns, endless pipes, storage tanks, and towering flames. But every structure has a purpose. Crude oil is a mixture of hundreds of different hydrocarbons. To separate them, the oil is heated to temperatures of around 400 degrees Celsius. The hot vapor enters a massive distillation tower. As it rises through the tower, different hydrocarbons cool and condense at different temperatures. Heavy products collect near the bottom. Lighter products rise toward the top. Among these valuable fractions is one that will become the foundation of modern plastics: naphtha. But the transformation has only just begun.
Naphtha is sent to specialized petrochemical plants. Here, it enters enormous steam crackers, operating at temperatures approaching 850 degrees Celsius. Inside these reactors, large hydrocarbon molecules are broken apart into much smaller building blocks. Among the most important are ethylene and propylene. These simple molecules become the foundation of countless plastic products. Through a process known as polymerization, millions of these tiny molecules join together like links in an endless chain. The result is a completely new material: plastic.
The molten plastic is cooled, cut into tiny pellets, and transported to manufacturers around the world. These small pellets may appear ordinary, but they are the raw material for thousands of different products.
Plastic pellets arrive at manufacturing facilities where they are melted once again. Depending on the product being made, different manufacturing methods are used. Injection molding forms precision components for electronics and automotive parts. Blow molding creates bottles and containers. Extrusion produces pipes, cables, and plastic films. Thermoforming shapes food packaging and disposable containers. Within minutes, the same tiny pellets can become medical equipment, automotive components, household products, toys, furniture, or packaging used around the world. The possibilities are almost limitless. Plastic has transformed modern society, but its success has also created significant environmental challenges. Today, engineers and scientists are developing new recycling technologies that allow used plastics to become valuable raw materials once again. Chemical recycling, biodegradable plastics, and bio-based polymers are helping reshape the future of the industry. The goal is no longer simply to produce plastic, but to create materials that support a more sustainable, circular economy. Innovation continues to redefine what plastic can become.
The next time you pick up a water bottle, use your smartphone, drive a car, or open a package, remember the remarkable journey hidden behind these everyday objects. From ancient oceans and underground oil reservoirs, to refineries, petrochemical plants, polymerization, and advanced manufacturing. Plastic represents one of the most extraordinary industrial transformations ever achieved. What began as ancient life buried beneath the earth has become one of the defining materials of the modern world. If you enjoyed this video, subscribe to The Industry Lens for more stories exploring the industries, engineering, and technologies that shape our world. Thanks for watching.